Electric car batteries may look like metal packs, but inside the factory they are built via chemistry, robotics, safety control, and precision engineering. Lithium, nickel, manganese, cobalt, graphite, copper, and aluminium arrive at the factory. Every material is tested for purity, moisture, size, and composition. Next, cathode materials are prepared. Lithium, nickel, manganese, and cobalt powders are measured, blended, and heat-treated to create active cathode powder. Graphite is refined for the anode, where lithium ions are stored during charging. Once the powders are ready, slurry mixing begins. Cathode powder is mixed with binder, conductive additives, and solvent to form a thick paste. The anode material becomes a smooth black graphite slurry. Now electrode coating starts.
Careful with the viscosity here. Got it. It's quite thick. Check the digital reading. Steady at 20,500 CP.
Cathode slurry is spread onto aluminium foil, while anode slurry is coated onto copper foil. The coated sheets pass through long drying ovens, where controlled heat removes moisture and solvent. The electrodes are compressed through precision rollers. This improves density, smoothness, and electrical contact. After that, the large rolls are cut into narrow strips. The edges must be clean because rough edges can create cell safety problems. A thin separator film is prepared next. It sits between the cathode and anode, preventing direct contact while allowing lithium ions to pass through. Now the battery cell begins to take shape. Layers of cathode, separator, anode, and separator are stacked with perfect alignment or wound into a tight jelly roll for cylindrical cells. The cell structure is placed into a pouch casing, prismatic metal case, or cylindrical can. Electrode tabs are welded to create strong electrical connections. Every weld is inspected to prevent heat or failure. Next comes electrolyte filling. In a dry room environment, electrolyte is injected into the cell. This allows lithium ions to move during charging and driving. The cells rest while the electrolyte soaks into the layers. After soaking, they are sealed. Pouch cells are heat-sealed. Cylindrical cells are crimped. Prismatic cells are laser-welded shut. Now the cell is complete, but not fully active. The next stage is formation charging. The sealed cells receive their first controlled charge. This creates important chemical layers and defines long-term performance. After formation, the cells rest in aging racks while the factory monitors voltage stability. Then the cells are graded. Machines test capacity, voltage, resistance, temperature behavior, and stability. Approved cells are matched by performance. Before module assembly, the cells are cleaned and inspected for dents, swelling, scratches, leaks, or seal defects. Approved cells are placed into module structures. Cylindrical cells go into holder grids. Prismatic cells are stacked into frames. Pouch cells are layered with separators and support plates. Bus bars are welded across the cells to connect them electrically. Sensors and wiring harnesses are installed to monitor temperature and performance. The battery management system, known as the BMS, is prepared. It monitors voltage, current, temperature, safety limits, and cell balancing. It is the brain of the battery pack. Cooling systems are produced separately. Aluminium cooling plates are machined and tested to control heat during charging and driving. The battery pack housing is then built. Large aluminium enclosures are welded, machined, cleaned, and coated. This housing protects the battery from impact, water, dust, and road vibration. Now full pack assembly begins. Cooling plates are installed first. Then battery modules are lowered into the housing with robotic equipment. High-voltage cables, bus bars, sensors, fuses, relays, disconnect units, and BMS wiring are connected inside the pack. Every cable must be routed securely. Every connection must be tight. Once internal assembly is complete, the top cover is lowered onto the housing. Gaskets protect the pack from water and dust. The sealed battery pack undergoes leak testing, then final electrical testing.
Initiate the leak test on plate 3. Copy. Starting now. Focus on the upper right nozzle. Confirmed. It's leaking. Flow is stable. Good. Log the pressure drop. Carefully install the disconnect unit, securing it with a torque wrench. Next, connect the multi-pin connectors, ensuring a firm click. Finally, place the relays and fuses into their holders. Double-check all connections. Pack aligned, ready for connection. Copy. Connecting cables now.
Machines check voltage output, insulation resistance, module balance, BMS function, and safety systems. Next comes durability testing. Battery packs face temperature cycling, vibration, pressure checks, water resistance testing, and safety inspections.
Sensors are online, starting verification.
Copy. Voltage sensors look stable.
Confirmed, plugging in diagnostic cable.
Connected. Running final test now.
All green, test complete. Initiating vibration test. Protocol is active. Readings are nominal. Acceleration is building. Good. Monitor for anomalies. No structural alerts. Test complete.
Approved packs move to final inspection. Technicians check connectors, seals, cooling ports, mounting points, housing quality, and terminal protection.
Lift steady, up we go. Alignment good, keep it centered. Forward slow, watch the stacks.
Copy, moving it now.
Clear path, proceed. All right, let's raise it up. Ready here? Bring it up. Good height, pushing it in now. Looks aligned, go ahead. Ready? Let's lift it.
Ready, lifting now.
Watch the sides, keep it steady. Looks good, holding steady. All right, it's clear. Stop the hoist.
The finished packs are placed into protective frames and delivered to electric vehicle assembly plants. At the vehicle factory, the car body is lifted and the completed battery pack is positioned underneath. Robots align it with millimeter precision. Fastening tools secure the pack to the chassis. High voltage connectors and cooling lines are attached. Once installed, the battery becomes the power source of the electric car.
EV entering the bay, rolling road test initiated. Battery system evaluation beginning, monitoring power output. Data looks stable, efficiency is within expected parameters. Connection locked, running final diagnostics. Power delivery stable at 150 kilowatts. Charge rate optimal, no faults detected.
And that is how electric car batteries are made, from raw materials to a complete power system. If you enjoyed this factory process, give this video a like, subscribe to the channel, and turn on the notification bell so you don't miss the next high-tech manufacturing video.